Alright folks, I'm going to discuss one way you might consider interacting with external services and between entity actors across an Akka cluster. I will start with demonstrating workflows in the UI and examine their progress through the lens of the Saga read model, which will allow us to peek into the progress of activities within a Saga. I will review some library code which allows me to think in terms of activity life cycles, adding, completing, failing, aborting, and retrying activities as events are received by the Saga. We will see how this underlying Saga actor and Saga lifecycle domain code is being used for several of the workflows in my app. So let's start by demonstrating how transaction updates coming from card issuer Lithic are consumed by a purchase Saga to coordinate interactions between account actors, employee actors, and an email service over RabbitMQ. Alright, so we got the Sagas coming in over here via signal R, and we got transactions coming in over here. That's good. App is running on Azure Kubernetes service. Let's see. Refresh the page to get rid of the incomplete ones. Okay. We got a few more, they'll complete eventually. Domestic transfers waiting for transfer service complete. Payment request waiting for payment. Yeah, so 11 transactions, about 100K pending. 100K pending, 11 transactions. Analytics. Let's look at the channel for a second. So we got our Postgres, our RabbitMQ, our scheduler, which has quartz on it, our web. Now we're going to look at how our purchase Saga ties into our integration with the card issuer Lithic. So I'm going to go ahead and create a card here. Alright, so when I submit this purchase, it's going to go to Lithic's servers. It's going to simulate a purchase request coming from a merchant's point of sale device, Tide++ merchant. You know, they're sending a purchase request over the card networks. Lithic is seeing that, and what they're going to do is, what we can have them do is send an authorization stream access request over to our application here, and that's going to, you know, check that the card has enough funds and that the account backing that card has enough funds, etc., etc., and get back to Lithic within 5 seconds. So let's start that off. Alright, so we see it in Lithic. Tide++ for $30. Amount authorized, $30. And you can see in our history we reserve $30 from the card balance, $30 from the associated account balance. Let's open up the diagnostic. Reserved account funds. Reserved employee card funds, wait for card network resolution. Send purchase notification. Alright, so that's the initial authorization request. Like I was saying, more events come in. We're expected to have a clearing, hopefully. And that can be for an amount that's the same as or lower or even higher than the authorized amount. Let's make it less than. So we can see that that clearing event came in for a $28 amount, $2 less than the authorized amount. Yeah, we consider the purchase complete at that point, but we could receive additional clearing events. I think for seven days typically, but up to 30 days for like hotel reservations. So, we still have to keep that Saga life cycle open to receiving additional purchase progress events from Lithic. So a typical scenario we'll see is multiple clearings. So we've cleared $28. Let's clear another 2. All right. So we created another 2 settle purchase with card, settle purchase with account. And then, yeah, we can see it here. It updated from 28 to 30. And we get 2 additional events recorded against the ledger. So maybe now we'll show an auth reversal. Let's make another purchase. So yeah, these additional activities, acquire account failure, acknowledgement, and the same with card, transpired from having this auth reversal on the card issuer updated purchase progress event. So yeah, we processed what that meant, and then we interacted. We created activities to subscribe an intent to have an activity that needs to complete at some future date. We sent out commands to our account and card actor to release those funds, and then when they do so, they get back to us. They get back to our Saga in the form of events, and that's what we see here. Purchase failure acknowledged by card event, purchase failure acknowledged by account event. And at that point, we don't have any more in-progress activities. Let's look at a payment workflow where one organization on the platform is requesting funds from another organization on the platform. And let's say that we want to do so on a recurring basis. So maybe once every month on the 3rd Wednesday of the month. We're going to see how the payment request Saga sends payment reminder emails as the due date approaches. When that organization fulfills their payment, that payment request Saga will schedule a new payment request Saga for the next recurrence interval and then complete itself. Finally, we're going to see how a transfer Saga originates from that payment request being fulfilled, and those transfers will be synced with the ledger in our partner bank. So we see we have an incoming payment request here from Dusty Robotics Company. Status is requested, and with a schedule of every month on the last Wednesday. So we can see the next 6 dates here. The next due date is the 27th, and then the last Wednesday of December would be the 31st, and then the last Wednesday of January is the 28th, etc., etc. So let's let's look at fulfilling this payment. Okay, we can see that it has been fulfilled. We'll view the transfer, and we can see that we reserved the funds from the operations account. The funds were deposited to Dusty Robotics, and then the transfer was settled. These are all events against the account actor. Let's go back and look at the payment request. And we can see that this one was fulfilled, and then another payment request was created for the next month, due December 31st. Maybe I want to show that a little bit later, not immediately after paying for the first one. That might be confusing. Let's look at the diagnostics, and we can see that the $7,700 transfer was made. Reserve sender funds, deposit to recipient account, sync to partner bank, settle transfer, send transfer notification, send transfer deposit notification. But that's the transfer saga. We need to look at the database to see the payment request saga. We can't see it here because it's the originator is the other organization, and we're only pulling in sagas where the originator is our organization. So, completed activities. Okay, so here we go. We notified the pair of requests, we waited for the payment, we scheduled the next recurring payment, and we aborted the wait for scheduled payment reminder since we paid early before these were scheduled. You can see this is the follow-up payment request saga that was created after the previous payment was fulfilled, with an inactivity timeout of 32 days. So in 32 days, our cron job's going to pick that up and say, hey, evaluate the remaining work, and it will see which one of these in-progress activities is ready to be executed. So right now, in-progress activities include wait for payment, wait for scheduled payment reminder, and another wait for scheduled payment reminder. So we're looking at the inactivity timeout, which is a time span that's like the smallest, the least amount of time until that activity should be picked up for processing. And so what we see here is that in 32 days, we'll send a payment reminder. Now in this payment request saga, the initial one, where we had the payment fulfilled, we can grab the transfer ID, and we can plug that in to our transfer saga. And then we'll see basically what we saw in the UI. Now let's look at a scenario where our saga needs to wait for human input before it can proceed. So we see that this ACH transfer here is in progress. We have a pending deduction of $931. Now we go over to the diagnostic where we see our sagas, and we see we reserved the sender funds. That was good. But then we failed waiting for transfer service complete. We failed the transfer service initial act. And now in progress, we have a wait for development team fix. So why is that? We can look at the events here. And what we see is our partner bank gave us a response when we initially tried to transfer to money from one account to another, and it says failed due to unknown error of counterparty not found. Okay, we can also see it in the database here. We see it has no inactivity timeout, so it's never going to be picked up by the cron job to be reprocessed. This is to say we're waiting indefinitely for a human in the loop. We're waiting for our dev team to fix what happened, the counterparty not found being an unknown error type. Okay, so you can see that if we keep trying to press this button, it will keep retrying, but it'll just keep failing. Transfer service act failed. Wait for transfer service complete failed. Transfer service act failed. Wait for development team fix. Activities in progress. So wait for development team fix attempts 3. Retry syncing to partner bank. Same. Retry. We can see here where we are codifying some string error from our partner bank response into a domain type that our application understands. So we can see the counterparty not found is commented out, and that is why we're currently stuck waiting for human input. If we add that back, restart the server, we got 931 still pending. So go back and retry now that we've fixed up the code. Reserve sender funds completed. Wait for development team fix completed. And release sender reserved funds. Now instead of having an unknown error, we have our domain type here. Yeah. So we go over here to the transaction, and we can see that the status is now failed. We've recorded the failure event against the ledger. Counterparty account not active. Refunded account operations. And we can see that the pending deduction is now 0. So let's take a look at some of the code here. We'll start off with a little bit of the types. Mainly the Saga lifecycle and the activity lifecycle. Saga lifecycle, activity lifecycle. And we'll see how those are used in an org onboarding Saga. But basically, Saga has multiple activities within it. Some are going to be in progress, some are going to be completed, aborted, failed. So every time an event comes into our Saga actor, we want to decide whether maybe one of the activities is finished, maybe one of them has failed, and what activities are going to come next. And then, based on what activities are coming next, we will interact with our environment. We'll interact with external services, we'll interact with other entity actors in the cluster. By sending them commands and waiting for events in return. So yeah, with activity, you see we got a start and end, attempts, max attempts. We have a notion of being able to retry an activity. And yeah, one of the things about my API is that every activity has some sort of inactivity timeout that we need to define. Like there's an assumption that you interact with some other entity and you expect a return after a certain amount of time. You expect some event to be received after some time. And actually, not all of them have to have a timeout. You can do it actually like way in the future, and then it'll take on the behavior of being a scheduled activity. But we can also wait indefinitely. That's also fine. So let's take a little bit of a look at that. Starting off with our org domain logic for our org onboarding Saga here. org onboarding saga. Okay, so we got a start event. Sometimes you can start the saga with different scenarios, but this one has just one, application submitted. And then we have a bunch of events that'll come in, org onboarding saga events, after the start event. Alright, and I think, like I said, based on what events come in, we will save new activities to be in progress or finish other ones. Alright, so this is pretty minimal right here. Basically, yeah, like all the sagas kind of look the same like that. And then all the handlers over here also look pretty similar. Okay, so we start off the org onboarding saga with an application submitted event. And from that, we create 2 in progress activities. The know your customer verification and the send application processing notification. From there, we'll receive a reply sometime later once RabbitMQ processes the outgoing email. We'll receive this event, activity send application processing notification, finish activity due to this application processing notification sent event coming in. And this is the know your customer service response coming in. We can evaluate that response either to continue on to the next step or do some error handling here. So here if we had an error with that know your customer service response, we would send another email saying, hey, your application requires revision. And we register another activity with no timeout, which is wait for info fix demanded by know your customer service by know your customer service. Flat out rejected, then we send a send application rejected notification. Alright, so next steps are create legal entity with partner bank. Alright, and the next thing is we're going to receive an event from our partner bank. We're going to say, hey, if there was an error, maybe we'll retry. Otherwise, if it's okay, we finish the activity and we create another one, which is create internal account with partner bank. Sort of goes on and on. When that activity finishes, then we mark the saga as complete. So those are, these apply event functions, apply start event. That is taking in an event that came into the saga actor, and it's writing a description of the current state and our intended assumed next behavior, if that makes sense. Alright, and if that was to be persisted successfully, then our event handlers get called, where the actual behavior is invoked, and we actually start interacting with the rest of the system and external systems. So we see that here. When the application is submitted, we get the email actor out of the registry, and we send it this org onboarding application submitted. We also contact the Know Your Customer Service actor so that, yeah, they can verify that we're like a legit business. You can see sort of here we're interacting with our ACA CRDT, our distributed cache. As one of the steps in the workflow. And here we're interacting with the org actor. Actually, I'm probably going to remove the org actor, and then it'll just be a database call. So yeah, let's go back real quick to this inactivity timeout. If one of those activity timeouts is exceeded, that is to say that like an activity has been in progress for over 2 minutes for this type of activity, then we're going to go ahead and try to invoke the behavior related to that activity again. And what we do is we have a cron job. Cron job is scanning the database every few minutes or seconds for, sagas that have work that's ready to be retried. And when it finds those, it sends a message to the respective Saga entity actors, or it sends an evaluate remaining work message, and then invokes that interaction with external services for a second or third attempt. And we can also set our max attempts here. Maybe we'll look at Postico. Look at Postico real quick. So we sort of saw in the UI a little bit of a nicer version of this. But basically this is the Saga table. This is the inactivity timeout. And this is the bulk of it here in Saga state. We have all the events. The status. And all of our activities. Lots of completed activities with one attempt. Our start event. So yeah, I just had this JSON B column to describe the state so it can have like a different structure for each of these different kinds of sagas. Yeah. The thing I'd like to touch on is making sure that the interactions between our entity actors and our sagas are idempotent. If we look at my parent account actor, you can see that I save the processed commands. I save a map, and then when another command comes into my account actor, I make sure that it hasn't already been processed. I also have this prune idempotency checker message running every 4 hours to make sure that I only keep the last 24 hours of processed commands. Alright, so when it comes to events coming into the saga, instead of commands going out of the saga, There's a lot of situations where other entity actors in the system are sending events to my Saga over ACA delivery, which has at least once delivery. So in those scenarios, so if we look at my events, there's no notion of like an event envelope with an event ID and then the event itself, just the event. But that might be an improvement for the future, but I think this invalid step progression check within my state transition will be fine for now. Yeah, so we talked about our apply event function and our on event persisted functions that we defined for all of our sagas. These are going to be passed into our actor props for our Saga actor. We're going to do persistence, event source persistence, the same way you're used to seeing it. Handling those persistent events by calling our apply event that we showed earlier. So if these sagas don't run to completion, I think it's within about 2 minutes. Then the actor is going to be passivated. It's going to basically shut itself down. It's not going to be in memory anymore. And the inactivity timeout that's saved in the database is going to be used in coordination with the cron job to basically wake the Saga actor up again and evaluate the remaining work. That's our check for remaining work message here. Alright folks, thank you ever so much for tuning in to my very first video. If you like what you saw today, give us a thumbs up, subscribe, and I'll see you in the next one. Cheers.